Hey there, welcome to another video on the Learn APL with Neural Networks series. In this video, we will set up the let's call it the script, the function that will be in charge of initializing a random neural network, so a new network, and it will train the network in the MNIST dataset, and then it will test its performance. It will assess how good the network is. So in order to do that, what we can do is we can create this new function that I'll call MNIST, and let's make it a thread fun because the thing that we want to do, the code that we want to write in here, is it kind of resembles a script, and when we want to write some functionality that is script-like, then thread funs are really good for that. So let's create this thread fun MNIST that returns the network, and it has a single argument that we are going to ignore. So let's just call it underscore. Now, the things that we can set up already are, for example, the path to the data files, right? Because we need to read the data, so we can go ahead and copy that path and paste it in here as a character vector. So that's one thing. And don't forget to localize these names, so path. And then another thing we can do is actually define a read chunk function. And what this helper function does is it takes a tie number from a file and uses quad CSV to read some rows from that file. Now we want to use the records variant so that it reads at most 1000 rows at a time. And so the argument to the diff is the tie number that goes in here as the argument to quad CSV. And then we give it an empty encoding so that it tries to guess the encoding, and then we give it a 2 to say that all of the columns should be interpreted as integers. And not only that, but we can also have this helper function that we will call split data. Now what does this function do? Let's also localize it in here. Split data. Now if you recall, the data that we read, I think it's still in here, so let me read some data. Let me read some data in. So let's read 1000 records. Now this write tag here is doing the same thing as parenthesizing the whole thing, so it's splitting the options of the variant to the actual argument of the function. Now the path is going to be all of that, except I need a character vector there. Yeah, so it's all of that MNIST test.csv, and then an empty encoding, and then a2 for the rows to read everything as integers. So there's some data there. Now the first column of the data contains the digits, so the actual digits. For example, if we take a look at just the first 10 rows and the first 10 columns of the data, what this shows is that all of the digits start with a bunch of zeros, but the first row is a 7, the second row is a 2, the third row is a 1, etc. So our split data function, what it will do is it will take a bunch of these records, so it will take a chunk of data. Maybe we should call it split chunk. It will take a chunk of data and it will split it in the first column that contains the actual digits and all of the other 784 columns. And so in order to get the first column, what we can do is we can use the left tag and a reduction. Notice here 72104, 72104. Now left tag reduce, what it does is it returns the first element of a vector when it's applied to a vector, and when it's applied to a matrix, it's applied to each row separately. So I'm returning the first row, and then to get all of the other rows, what we can do is, let's just do it on this a little bit, we can use drop to drop the first column. Sorry, this drops the first row. We can use drop to drop the first column like that, and notice that we just dropped all of the digits from here. Okay, so this is what the split chunk does. It returns these two chunks, these two bits. So it returns all of the digits, and it returns all of the information that is not whoops, I don't know, yeah, sorry about that. It returns all of the information that is not the digits themselves. So it returns all of the 784 pixels. For example, if I check the shape of 0, 1 drop of data, you can see that I've lost one column because the original data has 785 columns. So we need these two functions, this path variable, and now what does our script need to do? Well, first it needs to train the network, and then it needs to test the network, right? But if we need to train and test a network, then we need some network. And so what we do is we initialize it. And now what's the shape of the network? Well, the images have 784 pixels, so that's the size of the input. Then something in there, and then there's 10 different digits, and we need to be able to distinguish between them, so we have 10 different outputs. Now it's up to you what you put in here in the middle. You can have nothing in here, or you can have some other values. And for the purposes of this series, I will have 2 16s in there. And why is that? Because I know that in the end this configuration will work. And so if it doesn't, then it's probably because we have a bug somewhere. Well, in real life, usually you will not know what specific structures will work, so you would have to experiment with them. But I've already done this a couple of times, so I already know that this is a good place to start off at. And finally, after initializing the network, something we can already do is tie the files that we need. So we need quad and tie to tie the file. And what file do we need to tie? Well, for the training, we need to tie the training file. So that's path train.csv, and I'm using the commit operator there because I don't want to insert parentheses to change things, because the 0 here should be the argument on the right. And after I'm done with training, I can use quad untie to untie the file. And similarly, when testing, I can start by tying with quad untie, and I tie the test file with the test data, and when I'm done, I do a quad untie. And now this tie number should also be localized. So this is the basic structure of our script, of our function that looks like a script. And so what is next is filling up these two sections, right? And we will do so in the following videos of this series. So go stretch your legs, drink some water, and then I'll see you back for the next one. Bye.